In these slides, we're showing the Elastic Edge demo lab setup, which is here in Sunnyvale. This setup is made of a single server and it's composed of 4 virtual MX instances, 1 playing the role of the access node, 3 playing the role of a service node. On top, we also have Contrail Cloud single node deployment, on top of which the E2 Elastic Edge application runs. Additionally, completing the lab setup, we got a Postman client, an open source client that we use to issue REST APIs requests to the E2 applications for the different service configuration, service workflow orders. iPerf as a traffic generator, injecting traffic and demonstrating that we do have end-to-end traffic flow across the different network as an end-to-end path, and OpenNTI as a telemetry collector that provide the visualization capability of the end-to-end traffic which is crossing the network.
Elastic Edge application has 2 sets of APIs. One which is used to build a network, which is also called as the Network Builder API. It basically helps you to create a topology, adding the access node and the service node into the system, and also defining the connectivity between the access and the service node. The REST API basically looks like this. The first one is to add a network element. It takes the name of the router or the node that you want to add. In the first example, we have VMX access, the management IP of the router, and the role which defines what the node corresponds to, whether it's an access or a service. The next set of API is basically connecting the access node to the service node, and it takes the interfaces which basically connects from the access to the service side. The fabric basically explains whether you have an L2, L3 topology between the access and the service. If it's a null fabric, it basically creates automatically aggregate interface between the links. Now we will start our E2 app. We can see that the E2 server is up, listening on port 10,001. Here is the Contrail GUI, which basically shows that there are no nodes configured yet into the system.
We will show now how to create the aforementioned network topology using REST APIs on the Elastic Edge applications via our Postman client. This is the Postman client, so we have a list of pre-configured set of APIs where we can add an access node. We can see the body of the API where we got the name, the address, and role, and similar for the service nodes, service 1, 2, and 3. So what we'll be doing first is we'll send the APIs for creation of the access node itself. We have them created. We do the same for each of the services nodes. And then the last step is to check that all the nodes have been created. So we show all the created network app. So we can see that each one of them has been created. So we saw each one, the route IDs with its role and the management address which has been assigned.
Now, after the APIs were executed, we can see that the following 4 nodes have been added into the Contrail system.
The next step is to create the interfaces on the newly created node, the access node and the service node. So for that, we're going back to the Postman UI, and here we got the APIs to create the connection links or interfaces on each of the nodes. So we have those APIs whose body is going to show that on each of those nodes we're going to create 2 interfaces for each of the access and service nodes. So let's issue those commands. Specifically, we send those APIs and we see the connection has been created. Second command and third command issued. And we can see with the following API that we send a command and get a complete list of connection links or interfaces that has been automatically created by the Elastic Edge application into the VMX nodes of the setup.
Once we have our network topology fitted into the E2, the next set of APIs will help us to define and create service and place the service between the access node and the service node. The service API basically takes the following information. It takes the customer name, the access node, the port on which the customer traffic will be ingressing, along with the VLANs that the customer is defined as. And on the other end, it takes the service node where the service needs to be placed. Now, using the Postman, we will show you how to create a service between the access and the service node. So we are back into our Postman client. We have defined a red customer with VLAN 100, 101, 102 and an access port, which is the ingress port where the customer will feed the traffic into. And we want to establish service between the access node, VMX access, and service 1. So let's go ahead and issue this or add this service into the system. And as you can see, the REST customer service has been added into the E2. Now let's look in the background what all has happened.
This is the Grafana dashboard, the UI of our telemetry collector for our LAN network. Once we have issued the network builder via Elastic Edge, all newly created nodes and interfaces appear on the Grafana dashboard. Telemetry data is exported to our collector and then visualized as packet counts or packets per second for each node, physical or logical interface. We can see that all the nodes that we have created through the Elastic Edge appear here on the UI. We also notice that after issuing the service placement API, those services appear as pseudo interfaces or PS. And there is 3 pseudo interfaces, PS0.0, .1, 2, each one carrying DLAN as a service end-to-end from the access node to the service node itself. So far, since we are not injecting any traffic in the network, all interfaces and nodes show 0 packets per second. The next step will be to study Hyperf traffic generator. What we will observe is that traffic will flow through the end-to-end service path, and we will see traffic statistics increasing from the end-to-end service path from VMX access to VMX service 01.
Now we'll do the next step of things, which is moving the service from node 1 to node 2 in our existing demo. This is the current API, the REST API that we have for service movement. So as you can see, all it takes is the new node where you want to place the service. In the current example, we are going to place it in VMX service node 2. So in this, we will show you how the existing customer moves from service 1 to service 2. Again, we will use the Postman to issue the REST API command. So this is a move API, which basically moves the red customer from the original service node to the new service node. And let's go ahead and issue that command in the background.
So at this point, we can notice that on the node where the service has been moved, the traffic has started coming from the iGraph generator. So we see uplink and downlink packets passing through the new node. If we move to the previous node, we see that there is no traffic carried over the previous service nodes.
Using E2 API, a port on the access node is configured for VLAN auto-sensing. Through notification of the new VLAN on E2 controller, E2 will authenticate the incoming VLAN and eventually create the service path for the VLAN to be serviced. In order to test it, we'll be using ping, where each destination IP for ping maps to a specific VLAN between the access node and the service node. So we'll be using 100.0.0.2 mapping to VLAN 100, 101.0.0.2 mapping to VLAN 101, 102.0.0.2 mapping to VLAN 150, and all of these three VLANs will be E2 authorized VLAN as per the configuration on the E2 service DB. We will also be using 200.0.0.2, which is mapped to VLAN 200, and this is not a VLAN which is configured in the E2 service DB. So we will see that once the E2 has created the service path, ping will be successful. The next step will be to use the Postman client to issue an API to the Elastic Edge controller to configure a specific port GE000 on the VMX access node as an auto-sensing port. Now we will be sending VLAN encapsulated traffic to the VMX access node. Ping 101.0.0.2 sends VLAN encapsulated traffic using VLAN 101. As soon as we issue the ping command, we see that the controller detects the VLAN, authorizes the VLAN, and provisions service for VLAN 101. And then we see ping traffic going through. Now, we will do the same use case for VLAN 150 by pinging IP address 102.0.0.2, which is mapped into VLAN 150 on the VMX access node. As soon as we issue the ping command, E2 controller detects the new service request for a new VLAN, authorizes the request, and then we see the ping traffic going through as on the left window. Now, let's try to generate traffic on the access node for a VLAN which is not authorized by the Elastic Edge controller. For this, we will be using ping to address 200.0.0.2, which maps to VLAN 200. As you can see on the right side, that VLAN was not found in the authentication database of the Elastic Edge controller. Hence, it's not authorized, and then the service is not provisioned on the access node and the traffic doesn't go through.